Hello, this is Panda Consulting's ArcGIS workshop, and I'm Frank Conkling. In this workshop, what we're going to do is we're going to go over ArcGIS Pro Topology. There's not a whole lot of difference between ArcMap Topology and ArcGIS Pro Topology, but we want to review the basics. We get a lot of new people coming in, so this will allow us to go and do this. Before we start, I do want to just point out a couple things. The QR code here in the lower right corner will get you to Panda Consulting's website. You can find out who we are, what we do, why we do it, and who we have on our team. In addition to that, I want to point out that Panda Consulting is a silver partner network of ESRI, and we are the first business partner in the nation to receive the parcel management specialty designation. We also have the release ready specialty designation and state and local designation. And then finally, if you are here and watching the webinar live, just to let you know, Chris is actually going and moderating the chat window. So if you have any questions, comments, or want me to go and review anything, go ahead and put them up in the chat window, and he'll make sure that he interrupts me and that we get it identified. All right, so let's go ahead and start. So what is it that we're going to talk about today? We're really going to talk about topology. What is it? And we're going to get down to the fundamentals. What is it? How do we create it? How does it work? Those sorts of things. We're going to talk about the various components of topology, how to go and implement it. And then finally, we're going to start looking at topology rules, and then we're going to get over some demonstrations. So what is topology? Topology is a way with ArcGIS software to go and verify and check spatial relationships, both between data in a single feature class and the relationships in features in different feature classes. And what it is actually a topology object that gets defined, and that object goes and lists what feature classes are taking part in it, what rules there are, which feature class takes priority over others, and we'll go over some of these requirements and we'll look at them a little bit further. All right, so let's just dig into this and see. So this is ArcGIS Pro, and we have a couple of layers here. We actually have two layers here, and you'll note on here we have parcel topology, and this is the standard object of topology object when we go and load it up. But what is it that this topology object actually is and does? Well, let's look at the properties of the object. The first thing is that we have to recognize that topology has to exist inside of a featured data set. A featured data set is a collection of feature classes and objects that have the same identical spatial reference, not just the projection information, but the actual same resolution, the same reference. Everything that's together is the same. So that's the first requirement, is that it has to be inside of a featured data set. All right. And then secondly, what's the name of it and what's the cluster tolerance? The cluster tolerance you're going to find as I start talking about this a little bit more is a setting that actually gets pulled usually from the spatial reference that's set for that feature data set, but it can also be changed later on. It is, in fact, the smallest amount, the smallest measurement that you wish to have in which everything is considered coincident. Because really, topology is about coordinate coincidences. That's how it actually works. All right, so then the topology object actually goes and lists what feature classes are participating in a topology. Again, a topology is an object which allows it to begin to analyze how things relate to one another spatially. Now, one of the restrictions is that a feature class can only participate in one topology at a time. You can have multiple feature classes in a topology, but the feature class itself can only participate in one at a time. So once you go and tell it you want to participate it, it goes and adds that to that. The next thing that you identify is this ranking, this XY ranking. This is actually a numeric ranking, and the higher ranking, meaning the lower number, is it's going to go and pull objects that have lower ranking or features that have lower ranking. It's going to move them towards these that have the higher ranking. So the twos, if you have lines that are defined as a rank of two, when you go and perform topology validation, the first thing it's going to do is just going to take those twos and move them towards ones if in fact they are located inside the cluster tolerance. So it doesn't go and move them outside the cluster tolerance, but it only moves vertices and such inside the cluster tolerance. But the ranking is important. On this example here, you'll notice that they're both ranked the same, meaning just pull them all together so they are coincident inside of here within that cluster tolerance with no preferences being given to one or the other, no priorities at all. So it lists the feature classes. And again, the way you identify which is more important than the other one or which one you want to move to the other one is by the ranking. And I can actually increase the number of rankings, at least I can have as many as the same number of rankings that I have feature classes included inside of here. All right, the rules. The rules are what you actually go and tell it, I want to check for these things. And these rules, we actually have an entire poster available for you, and we'll show that in a minute. And the rules are going to go and allow us to go and analyze how it reacts and how it's related to one another. Let's look here at this very simple example here. It says that the PLSS comms, actually this is actually PLSS topology. This isn't even our tax parcel topology here, but it's telling you that in fact the polygons, the points on here must be covered by lines so that we cannot have points that are not covered on the line or that are not actually located on the line. And the borders is that the lines must not overlap upon one another. Finally, that they must not have dangles. So we have a question in there. So is editing the feature class based upon the ranking? No, editing itself, topology and topology validation is different from the editing. You can go and edit things completely free of the topology, meaning it's not impacted by any of the settings on the ranking. That's a very good question, though. All right, and then we have another question regarding fixed survey points in a separate layer with a higher ranking than the other features. They can be in a separate layer, but that doesn't necessarily mean they still have to participate in the topology. And that's sometimes a special case in which others are going and using that for parcel fabrics and things of that sort. So let's continue with this. So this is the rules. Here's errors. If in fact we generate a summary, now the summary goes and looks at validation, it checks the rules, and then we'll tell you whether or not there's any errors in there, and then finally whether or not we have any error tracking on here. So let's go through this a little bit. I didn't realize until just now, this is in here. We actually are looking at this topology. So here's the topology. In this case, we only have one feature class in here. That one feature class is called tax polygons. When we look at the rules, it says that the tax parcels, in this case, must not have gaps. This is a common rule that we'll use sometimes, that historically we've been using in non-parcel fabrics, and that you must not have gaps, meaning you're looking for small gaps between parcels. Also, here's another one that says it must not overlap. This is indicative of an older data model in which we were trying to make sure that all of the parcels were not overlapping on top of one another. Problem is some of the newer ways of modeling parcel data is that we're allowing stacked parcels, such as condominiums and apartments and things of that sort. So we don't use these two rules as much as we used to use them in simple feature classes inside the parcel fabric. So in the parcel fabric, you may not use these rules, but it does allow you to go and add them on here. Let's look at the rules. All right, let's go back here. What are the rules? So here's the properties we just talked about. We have the general properties, what feature classes are included, what rules are associated, what errors and management we have of that. And here is a PDF that I've found very, very helpful. And this QR code will get you to ESRI's download site for this so that you can actually go and download. In the meantime, let's actually look at that PDF. This actually gives you a good indication, especially since they've color-coded them with the blue being Polygon-related attribute rules. And we can see here, must not overlap, must not have gaps. But we can include other things which deal with others, such as must contain a point, or contains one point and not many points. So in this case, this rule says it must contain at least a point. This rule says it can only contain 1 point. And we can go down through all of them, must be covered by a feature class. So usually it's a line feature class, but it could be a polygon feature class. The boundary must be covered by lines usually, and it will show you on here with the icons how they relate. In this case, this is polygon to polygon. This is polygon to line, polygon to point, and this is very, very helpful. Again, the line or polygon, this is one called the error must be larger than the cluster tolerance you'll find often. The green ones are line rules, and I think at the last time I checked, there was something like 29 topology rules that are out there. Polygons, lines, and points. This is very helpful, especially if you're just starting to learn how to go and create a topology. I'm actually going to create a new one on here just to go and illustrate what's going on. So let's go back to here. And what I'm going to do is I'm going to go and remove this from here. And I think this was the parcel topology. I'm going to go and actually delete this. All right, so I'm going to delete that parcel topology, and I'm going to create a new one. And on this new one, I'm going to go and I'll include my tax parcels, and I'll include my construction lines in that. I have my tax parcels here. I have my construction lines here. So let me go and create a new topology. And I'm going to right click and say new on here. And it will go and say, I want to create a new topology in here. And we can define it. In this case, what's the name of it? And no spaces. So we have that. Here is the cluster tolerance that I pulled off of our feature data set. And again, I want to include this line, and I want to include these tax parcels in my topology. My next step is to add a rule. So the first rule I'm going to do is I'm going to go and say my tax parcels, again, the rule must not have gaps. And my tax parcels must not overlap. Let's add those again. And finally, I'm going to add one that the tax parcel must be covered by a feature of, and this is the way to read this, must be covered by a feature class of area to area. No. The boundary must be covered by area of area. No. Let's go and look at the lines. Boundary must be covered by area line. And it's going to ask me what is my second feature class, and it's going to be those construction lines. So it's fairly simple once you understand what the rules are doing and You just want to make sure you're paying attention and don't get the wrong rule on there. You want to make sure you're including the correct feature class A and feature class B when you're going and building this. Now, if you note, let's go in here and go next. Here's my summary on here. I can go ahead and go ahead and create this. Note, when I create it, I let both of them have a ranking of 1, which is fine. But it will go and, again, I don't have much attention on paying for any of these other than I just want to make sure that I start looking at the spatial components in here. Turning off my tax parcels. Here's my construction lines that I have. And note, I have several things here that don't have lines on them. And I have lines on some of these in here. So my rules say several components on here. Before we actually go and look at the rules and validate them, let's do a couple of other things. First of all, in order to really interact with and have them so that we can go and identify the errors more easily, we want to go and add those rules, and that is where did we actually add that? You can tell by the way that workspace topology. Let's go ahead and add that to our current map document. And you'll note there's several things in here. There's something called a dirty area. Dirty area, when I turn that on, if in fact the topology has not been checked, it's marked with this dirty area. And we'll explore that a little bit more. And then we have different types of errors. We have point errors, we have line errors, we have polygon errors, depending upon what the rules are. And it will show us different symbology depending upon what we do. So let's talk a little bit about what topology actually does. So as we're getting ready to go and look at topology, there's actually 3 steps that it goes through. The first step is it actually goes and takes all of the features inside the layers that are part of the topology and intersects them. All right? Because it's going to go and check where they intersect. So the first thing it does is called a cracking. The cracking goes and intersects all of the features inside of the topology and inserts, if there's no vertex in there, inserts vertices where they intersect. Now, that's very important if you're looking at the quality of your data, because that means that if you include a layer that you don't want to have vertices inserted on, as soon as you validate topology, it's going to start adding vertices to that anytime it intersects with any other layer that's defined as being part of that topology. I'll show you shortly how one of our clients handled that, and that they have different topologies for each of the different feature classes they're checking. But when you're looking for feature classes or spatial relationships between feature classes, that's where you run into problems. And so let's finish this and I'll show you some other things in here. So here's the first thing is the cracking. That's the number one thing it does. It goes in and intersects and inserts a vertex on every feature that is included inside the topology anytime they intersect. So if I'm looking down here, it would insert a vertex right there at that point. It will insert a vertex here. It will insert a vertex anytime that it intersects these things. Doesn't mean it splits the line. It just means that it inserts a vertex in here. The second step is called clustering. And this is the step in which that cluster tolerance and the ranking becomes important, because what it does during this step is it goes and pulls them together and says, I want to make sure that these are coincident. So if you've got multiple vertices that fall within a cluster tolerance, it will go and pull them together according to the ranking. And again, just to go and remind you, the cluster tolerance is here. This is the cluster tolerance. So if we have any vertices that are closer than, in this case, 0.00025, it will pull them together and say, for these topologies and for this exercise, we are going to consider them coincident. This brings up a point that those of us that have used topology and ArcInfo software for a long time, we have what we have historically called coordinate creep. Recognize again, coordinate creep occurs every time you go and validate topology. But what I want you to remember is that that coordinate creep is within that limit, the cluster tolerance. It doesn't mean it's going to move things feet, but what it does mean is that every time you validate topology, there is a possibility, not necessarily a probability, but a possibility as you're starting to add things and do them, and it goes and cracks them, inserting vertices, and then it clusters them and pulls them together, that these things will start moving. Again, tiny, tiny, tiny amounts, but they will start moving on there. So just be aware of that, that there's that thing called coordinate creep. That's number two. Number three is once they've clustered everything together, it then goes and looks at the rules and validates the rules and analyzes them and identifies where there might be an error in here. And again, it's looking at the coordinate coincidence of those vertices and analyzing the features that come off of it. So for example, if it says, well, does this polygon have a line on it? What it's doing is it's looking at that edge of that polygon, and then it's looking at the actual vector of that line and saying, are the beginning points and ending points the same on here? Then in fact, this is the coincident and we don't have to worry about it. But if they are not the same, then it says, oh, then we have an error in here. We have a problem with this. So let's actually go and look at validating this simple topology that we built here. First thing we want to do is let's turn on our dirty areas. This will show us everything that has not been checked, or in topology verbiage, that has not been validated. By the way, there is a way to go and do a mass validation by right-clicking on the topology object and doing a validate. Depending upon the size of your data, I would say don't do this. It will take a while sometimes, but it's a good way without having to get into editing to say, do I have any errors out there? And you can just let it run. I'm not going to do this for this workshop. I'm going to do it the old-fashioned way. I'm going to start editing. So I'm going to go in on my quick access toolbar. I'm going to enable editing. I'm then going to go to my edit tab. The topology validation is located on the edit tab inside the manage edit tab group. And it's here that we can see the various types of topology that we can have inside of ArcGIS Pro. We can have it analyze no topology, and that it just won't let us do any of it. Map topology is basically the topology of the things that are being displayed in which it will analyze it. So if you want to move something, if it's connected to something else, it will move both of them. If it's not, you can move just the one thing. The workshop topology, this is the topology that's rule-based, and that's the one that I've gone and defined, and that's the one I want to go and validate. So I will tell it I want to go and validate that. The next thing I want to do is I want to open up the error inspector. The error inspector is the pane or the interface into my validation, into the work that I'm doing with this. And if I have multiple topologies loaded onto my map document, I'll see them here. In this case, I only have one. And I can tell it, do I want to validate my map extent? And right now this is enabled. Or do I want to, if I disable it, it will validate the entire data source. Let's just do the map extent now. Over here, it will show me the rules that I have in my topology. In this case, it will show me all the errors for all the rules, including exceptions. And we'll talk about exceptions in a minute here. So let's go ahead and validate it. Now, when I validate it, all right, what it's done is it's gone through and analyzed it and come up with a series of errors that are out there. So if I'm going to zoom out a little bit and show you that it only validated that portion of the dirty area that was in my current map extent. So just be aware that when you go and do a validate against your map extent, it doesn't validate everything. It only validates what's in your current map extent. All right, let's go back here to my view. There. So here, notice as I zoom around here, if I zoom over here, it is dynamically showing me the errors that are inside my map extent, which is nice. Never used to do that in ArcMap. I like the fact that it does it now inside of Pro. It also, in Pro, gives us this preview area so we can see where this error is. Matter of fact, if we go here and we right-click on this button here, it will actually allow us to zoom into it and say, oh, this is the overall error here. If we have an individual boundary, we can right-click and zoom into that, and will show us in yellow the error that we have highlighted or selected. All right, let's go back to here and go through them. So when I'm looking at this, I'm looking at what errors do I have here? This first one is must not have gaps. And this is the problem that we have with this topology rule as it relates to parcel mapping. Because what this is identified is that there is a gap between these adjoining polygons and the road. Well, that means that if you put this rule on your parcel layer, you have to have roads in there then. You have something filling in that space or that gap between them. I'm actually going to go and create a feature. I'm going to go and create a parcel that fills that in just by going over here to my create, and I'll go to my parcel, and I'll use one of the tools here. I'll use the autocomplete polygon, and I will go and automatically create one there. Notice what it did is it went and took that gap area and automatically calculated what polygon I would need to fill that thing in. But more importantly, as it relates to topology, it marked the area or the envelope that I just built as dirty, meaning it has not been validated. So every time you make an edit, every time you add something, it's increasing your dirty area and checking to see whether this has been validated or not. Just a little bit of trivia. In old ArcInfo workstation, we used to call this the edit mask, but that's what this is doing. So let's go ahead and validate this again. And let's unselect that. And note, we have a gap error here, but the gap error is over here. All right, so now I have that the boundary must be covered by a line. That's here. And if again, let's go down here and show you, if I turn off my parcels and if I turn off my errors here, I can see I don't have a line here. I don't have a line here. I don't have a line there. That's what this is telling me, that it's missing lines on these. Okay, so what I really like about ArcGIS Pro is that it allows you not just to see a preview of the error, but give you more details about it. It tells you a little bit more about what these are, that in fact, this is the feature identification for the actual feature that's got the error associated with it, and that it must be covered by a line. And if we hover our cursor over it, it actually will show us what that error is, which is very nice when we first start to get used, and then what the other second feature class is that's involved in this. At this point here, we also have this button that says we can mark it as an exception, meaning I have a rule, but this is an exception. I really don't have to check that anymore. I'm not going to go there. I'm going to go to the fix. So here, again, this is really nice. It allows us to go in here and say, here's the list of possible options that might be able to go and fix this. In this case, this is a simple one where we either mark it as an exception, which is our choice here, or we can go and create a line over this here. And if I click on create line, it will create a line for that. It then marks it as dirty, so I can validate it again. And now that's no longer dirty. I now have a gap error here, and I have that the boundary must be covered by lines here. So it's a process of going through and identifying all the errors in here. So here they are. So let's go in here and say, let's look at a couple things. Let's look at this must have gaps. I have must have gaps. I have an option. I can say, create a parcel that fills in that gap. All right, so I can go ahead and say, go ahead and fill that in. Marks it as dirty. We can then go in and validate it again. Now, our error has to do with it doesn't have a line on the boundary of it. So these are all the same type of error, must be covered by and always here. So I have an option. I can click on this one and fix it, that one. I can click on the next one and fix that, or I can hold down the Shift command and click on all of these. When I do that, if I look over here, it's going to say you can create all and fix all 10 of the errors just by telling it to create the lines for me. So simplest type of fix, I can say just use that standard default. Again, marks it as dirty. I validate it, and it is now free of any topology errors. Simple, seems very easy, but it gets more complicated as you get into the different types of errors that you might be able to find. Let's go in here and let's create another error. In this case, I'm going to take a parcel and I'm going to go and give it an automatic overlap. Now we have a rule that says it can't overlap. We have a rule that says it can't gap. We also have a rule that says it can't overlap. When I validate it, suddenly I have one, it says that the boundary has to be covered by lines. Let's go ahead and fix that. All right. Let's go ahead and validate again. Then it says we've got the must not overlap. Must not overlap is a very interesting error in that there's multiple ways that we can fix this. Notice, by the way, one of the interesting things about this, even though it's only one polygon, all right, even though it's only one polygon, it's giving me two errors because it's analyzing this data from a topologic standpoint. It's saying this part of this polygon is analyzed because of the coordinates that are associated with the lines that were intersected and the fact that it considers these two different parts of that topology on here. So is this one, and then if I click on this other one, it's the other one. So just be aware that it's one feature, but it's actually two different errors because it's intersecting two different, or it's overlapping two different polygons in here. All right, so let's look at the fixes for a must not overlap. I can create a feature. And what the created feature is going to do, it's going to create a new feature from the error shape. But is that going to fix my error? No, because that's going to create another parcel on top of this. So this is really not a fix for this. This is just going to go in and continue to give me more errors. And just to show you, I can say create a feature. It goes and creates that. And then Oh, what happened here? What it did is it actually cut it out. It wasn't really a create. What it really was saying is that it's going to create a split between those two. So just to be aware, let's go in here, back to this. Let's go in here. The create option actually is going to create a separate geometry. So it's really doing a what we in parcel mapping calls a clip. It's clipping it out of this other one that it's laying on top of, and it's creating a smaller one just for that. Probably is not what we want to do. But in this case, we can just expand. So just be careful with these. You want to test them and see what they do. The second thing is a merge. This supposedly merges the overlap into one of the two things that are on there. All right. You have to choose which feature is going to overlap. So when I click on a merge, it's going to give me, do I want it to merge into this one or do I want it to merge into this one? And again, this is actually talking about the overlap area. What do you want to do with the overlap area? I'm going to tell in this case, merge it into here. It then goes and gives me dirty area and says, okay. So what do I have here now? I have this polygon here, and it said, that's not an overlap because I've merged it over into this other one. So I still have this one here. Note what happened again. It clipped it out for me. Not what I want to do yet. Still not there. All right. So let's validate it again. Let's make sure. Here's the parcel. My fix is I can do a create. I can do a merge. I can do a remove the overlap area. And this removes the overlapping portion of the feature that's causing the error. What happens when I do this? When I do this, it goes and let's validate it. It clipped it out, but it threw away that parcel. That might not be what I want to do. I want to make sure that I have the right thing that I'm doing here when I'm going to go and merge this. Let's validate it again. I have one more option here. So this is going to clip it. It's going to clip it out of the parent parcel in parcel mapping terminology. This is going to merge it, but it's still clipping. This is going to go and remove it, so it's clipped again. I can mark it as an exception. Now, when I mark it as an exception, note it gives me different symbology. That's this symbology here. The exception is noted here. The error is noted here. So I've marked it as an exception so that as I validate this more and more, it's not necessarily going to show me that that's an error, but it's going to say, you've marked this as an exception. And actually, if I go back over here to my rules, I have the option to show or not show exceptions. So maybe I don't want to show the exception. And let's validate it again. Here's my rule. Here's my rule here. Same thing. I have to figure out what I want to do. Let's go ahead and mark that. It doesn't show me the rule here. It still displays that exception as being part of it there. So you want to learn what the rules are. You also want to learn what the fixes do and how to go and manage this. The reality is that fixing topology is an extremely iterative process. Let me go and show you a couple other things here. And as we go, I'm going to turn off my dirty areas here. I'm going to go and also take my lines and I'm going to go and symbolize them. All right, I'm going to go and just symbolize it with a single symbol, makes it very easier to go and display these, but I'm also going to add some other things. I'm going to add, so I want to see the vertices in here. So I'm going to add a couple of marker symbols on here. All right, and on this first one here, let's go close this out here for a minute. On this first one here, I'm going to go and go over to my properties, take this one. I'm going to make it smaller. I'm going to make it red. And I'm going to tell it to go and place this marker, not along the line, but on the vertices of that line. And then finally, I'm going to take this one, tell it to put it on the extremities of that line. Let's make it smaller. All right, so now we can see here that this data actually has, here's the one line, here's the extremity, here's a vertex on that point. So what happens when I go and create a line, any line? Yeah, let's do a line here. When I create a line on here, as I create it here, it looks like just a single line. Same way with this boundary here. But as I go and validate topology, if I'm looking at here, and I validate the topology here, it's actually going to go and insert the vertex here and here on this line, on this line, on this line. On the polygon, it's going to insert one here and in here as part of the first step in validate topology, which is cracking. And then it's going to cluster just in case there's any slight variations. And then it's going to check the rules. So here they are here. And now, just to make sure, there is my inserted vertex. Here's my inserted vertex here. If I check them on my polygons, let's go and insert markers on the polygons also here. I actually already had them on here. It will show me there it is there, and there it is there. So, when I mention this, I often talk to people about this, that in fact, often what we'll have is you'll have this cracking and clustering and it will have the coordinate creep, and they sort of get very concerned about it. Again, you want to recognize that this creep that's occurring is actually a very, very small area, but accumulates over time and accumulates and accumulates and accumulates. All right. So this is sort of simplistically what happens inside of topology inside of ArcGIS Pro. You have dirty areas, you have the different types of symbology for the errors, both the exceptions and the errors. With your error inspector, you have the ability to identify your errors. Once you validate them, identify the errors, you can fix them one by one. All right, and notice when you fix them, it goes and marks a dirty area again, or you can go and select multiples on here and then fix them at the same time. You want to make sure that you give this an opportunity to go and read all those errors and then tell it to fix them, validate them, and move on. Be aware of some of those polygon errors because the fixes, the quote fixes, may not be really what you want to do. You want to make sure you understand what the fixes are actually allowing you to do. I must tell you, the design of topology, you need to know what you're doing. You need to know, and so you want to understand what the rules are and make sure that you understand your data design so that you can have some topology that you don't wind up with 3,000 exceptions because that really wasn't applying on there. So let me stop here for a while. I don't see any additional comments in the chat window. Chris, do we have any other questions?
Nothing right
Anybody?
now.
Okay. So you can get very sophisticated with topology. This is a very simple one. Let me show you what one of our clients had done. This is another set of layers in which, and again, inside this, they actually have multiple topologies. on here. So they have topologies for different groups of layers. I actually think I might have taken and deleted some of these in here. So this one actually has construction lines in it, and it just deals with whether or not they have gaps or overlaps on here. Um, that's one way of doing it, so that when they're analyzing it, they're analyzing whether or not when they're building lines, whether or not it's actually they're putting the lines together, whether they have dangles, whether they have undershoots or overshoots on here. That's not a bad idea when you're going and doing that if you've got no other way to go and figure it out. It does require that you have to run topology, you have to run validate topology, open up the UR inspector and run all that. Um, Not a bad idea. The next one, this is some parcels, and in fact, I went and deleted this, so that shouldn't even be in my, that's the one that I deleted. Here's a municipality topology that they have, in which they have, again, gaps and overlaps. This one makes sense, because if in fact I have a gap or an overlap between a municipality, I may want to go and make sure that all of these are coincident. By the way, we have an entire YouTube video just on going and fixing and adjusting topology errors using some of the adjustment tools that are in ArcGIS Pro. Really nice tools now. But gaps and overlaps, you want to go and look at it. You want to understand whether or not your data really should have gaps or overlaps. In this case, for example, you've got municipalities. Well, what about unincorporated areas? Are you going to have a polygon for the unincorporated areas inside of your data set? If you are not going to build a polygon for that, then when you have a gap, all your edges are going to show up as exceptions. So again, you want to think about how you go and build this. PLSS topology, this one they also have that the lines themselves must have a point on the end of them, and it has a boundary point line. And if you look at the rule itself, it says the point to line, so that this must have a point on the end of the line, or on the line, not on the end of the line. This one says that the lines must not overlap, and this one says that the lines must not have dangles. So these are kind of standard types of topology rules on here. As we get into more sophisticated things, what happens if you're designing a data set and you have something like this with these construction lines? And that what happens if I have multiple types of lines? How do I go and create topology rules that only apply to certain lines? Well, the only way to do that is to actually, instead of using a simple attribute, you actually create a line subtype. So let's go in here and look at this design. I suspect they actually have subtypes on this. They do. They have a line subtype here, so that that line subtype, all right, if I go and build construction line topology on here, let's go to this. Let's make sure this is the construction lines in here. Okay, it has construction lines in here. Let's create a rule that says the annexation lines have to go and be covered by a boundary. Well, in this case, we only have one feature class in here, right? No, we have. So let's put SimCons in here. And let's go and create a rule that says that in this case, the construction lines subtype, the annexation, must be covered by the boundary of, in this case, SimCons. So if you wish to get a little finer in the way you go and define topology, you have to go and subtype them so that it can differentiate between those. So again, you can get very, very complex in the way you are building your topology rules and the way what you're checking on there and validating on them. It's a great tool, but just be aware of there's limitations associated with it. All right, so I think I'm done. Are there any other issues? Let's look at what else we have. Hopefully you've all gone and downloaded this and have it in your library. This is a really helpful poster. Print it out, put it up on your wall. I used to have it on my wall. It helps a lot when you're first learning topology. Again, we talked about the error inspector. We looked at the fact that we can actually choose which topology it's actually going and doing it. If we have multiple topologies in here, we can validate just our map extent, the overall extent. We can choose which rules it displays, whether or not it shows exceptions or not. By the way, you can switch selections on here also. When you have something selected, it will show you a preview, and you can also go and look at the details or the fixes on there. I really like the way ESRI has done this now. It's only going to show you the rules that are inside your current display area. So it's nice improvements over ArcMap and the topology in there. And then the demonstrations. So if there are, oh, we have a question. What sort of rule would you use to ensure that, for example, tax parcels don't overlap the boundaries of the PLSS sections? So if in fact you have something like that, you then go and develop a topology rule. Let's go ahead and do something like that. We have multiple polygon types in here. And let's look at this was our workstation topology that we had here, right? And we had two feature classes. We had tax parcels and we had our lines, but let's add another one. Let's add our SIMCONs. Our SIMCONs are simultaneous conveyances. Again, this will just make sure that we identify what's in there. You want to know your data. So we do that. Now, once we've added that, we can now add a new rule. And the new rule says, in this case, tax parcels. All right. We can add a rule that, in fact, they must be covered by the polygons or the PLSS. All right. Now, here's where the question says, well, I want to do the inverse. Can I say must not be covered by and must not overlap on here? So here's the rules that we have for this must not overlap. Must be covered by, must not overlap, must be covered by the boundary of an area or a line. So there is none that specifically say that it must not be covered by that, other than it can't be on the area. So if you're looking at the boundary, again, you've got must be covered by an area. This is area. In this case, is go to check to see whether this parcel is on top of here, whether or not it's a complete coverage or not. This is covered by a line, must not overlap on here. So this is going to tell you whether or not the parcel is covering the polygon. Again, you're analyzing polygons to polygons. Perhaps what you really want to do is you want to ask whether or not the boundary is covered by, must not overlap with, must not overlap, must be covered by area, must not overlap with an area, must not be covered by a line. So yeah, you can't do negatives. You can only do positive, except for those areas where it's looking for overlaps between two. So you can make sure that the parcel isn't inside the section. But the way I understand parcels and sections, that may not be what you want. I think what you might be looking for is that the parcel boundary must not be overlapping a subdivision boundary somehow. So it's an interesting question. We'll talk more about that afterwards. Otherwise, anything else? All right. Then let's go ahead and end this. Thank you again for everybody. Stick around. We're going to have some more questions.